Welcome back to FP 101. If you're new to the series, in the first couple videos, we touched upon what algebraic data types are, or ADTs for short, and in the second and third video, we touched on type classes and what those are. And in a nutshell, ADTs are different data types that we use to wrap our values within our application, while type classes expose different behaviors that we can use to operate on, to manipulate that data, or to get it in the shape that we need it to be. That might be an oversimplification, so if you are new to those concepts, please jump back into the other videos and take a look for yourself for a more in-depth explanation. Now, after that, we talked about using either ADT to build out form validation. And in case you missed that, either essentially wraps a left channel and a right channel. And convention dictates that in the left channel, we have errors, and then in the right channel, we have success values. So today what we're going to be talking about is this ADT known as TaskEither. And before I get into that, let's just briefly talk about what a task is. It's an algebraic data type that represents some asynchronous action that doesn't have the possibility of failure. Let's just say that you set like a timeout function to console log to the browser. We could pretty much guarantee that that's not going to fail, right? So you could wrap that in a task. Now, if you have something like a network request with the possibility of failure, this is where TaskEither comes in. And it takes the notion of a task or the concept, and it takes the concept of an either, smashes those together, and you have TaskEither, where you have asynchronous actions that have the possibility of failure. So there's some time that it's going to take to resolve, and then when it does resolve or it rejects, you're going to have errors or you're going to have success values. So you're going to see what we could do with that concept or with that algebraic data type in this video today. And to help me explain this a little bit better, I've invited a good friend of mine and fellow software engineer, Tylor Steinberger. He's going to walk you through the code that he built out to help explain these concepts in a way that should be a little bit more consumable. In a nutshell, what the purpose of this code tour is to show you how we'll use TaskEither to wrap some asynchronous side effects and how we can compose multiple network requests together. In addition to that, he's built out custom hooks in React to make sure that we're pattern matching on all possible states. So without further ado, let's go ahead and pass it over to Tylor, where he's going to walk you through this stuff.
Hello everyone, welcome to FP 101. My name is Tylor Steinberger. I'll be your guest host today as we dive into FPTS's effect types task, and more specifically TaskEither, building on the either examples that you learned in the last video. So first off, what are tasks and why are they useful? Tasks by themselves represent an asynchronous effect that is lazily executed and must never fail. So let's take a look at an example showing how to put together a task. So right here, you might already notice, we have this function delay here, and it takes a number in milliseconds, and it returns a task of void, so it returns no value. So I mentioned tasks being lazily executed. Unlike promises, promises are eagerly executed. Tasks essentially make promises lazy by giving them this extra function to return a promise. So this allows you to build up computations involving many promises and execute them in parallel, race them, all kinds of things. Secondly, I mentioned that tasks must never fail. So this is a guarantee that can't be proven at the type system, but is something when you read task in FPTS you can always assume, or it should be a guarantee that all of these tasks will never cause a promise to reject. So if you ever find yourself writing reject in a promise when you're trying to return a task, you might be looking for the wrong thing. Which brings us precisely to the talk at hand. We're going to get more into TaskEither. TaskEither being the task that returns, well, neither, And instead of using promise rejection, we use an either to represent errors or successes. So now that we've built up some intuition around task, I'd like to show you a React example using TaskEither. First, I'd like to show you what our example is. So we're using the open source Star Wars API. This API allows us to, as you see here, first ask for a set of characters or people that are found in Star Wars. We can then select a person, and it will load the video, the films in which those characters have been seen. And then the only other feature we got in here is pagination. We're going to be able to switch back around different pages to see different characters, and ultimately what videos they were seen in. Alright, so now you have an idea of what we're trying to get into. I'll start to break down how I went ahead and implemented this example. So I'll work my way top to bottom. We'll drill into each of the implementation details, talk about why I chose them, anything else that comes up along the way. Alright. So here's the entry React component to this example. At the top level, we're managing most of the state involved in this application. So first, here we have a custom hook called use TaskEither, and use TaskEither helps us manage the lifecycle of a TaskEither. Given this time in milliseconds, it will ensure that any requests made using the TaskEither will wait at least that long to show the loading sequence, just for user experience. And what we get back is this function called we named match people, and what it's able to do is pattern match on all of the different states that our TaskEither can be in. So in this case, we have 4, technically 6 states that we want to represent. So the first being you have none. So in the case where your application just started, you haven't made a request yet, the state you would have is none. The moment you start loading, you'll be in a loading state. The second function captures that. And the third function captures the error state when the task has resolved with an either that is a left. And the fourth function will be called when the task resolves with an either of a right. And this allows you to very declaratively map over each of the outcomes we can expect. Additionally, the third and fourth functions also take in an isLoading flag, has a second parameter. That's why I said technically 6 states. We can also have previously had an error, but we're currently loading to get something else. And likewise, we can be resolved with some sort of value, but also fetching the next set of information. So let's take a look at how use TaskEither is implemented. This is implemented all using React hooks, mostly React use state, use callback, and there will be some React use effects later on. So the first bit of information is keeping track of the current value. So here we've chosen to use an option of either to be able to represent the states that we have no data, where the option is a none, where we have an error, where the option is a sum with an either that's a left, or we have a successful value when we have a sum with either that's a right the value. Additionally, since TaskEither deals with asynchrony, we also have another use state here for tracking whether or not the current task is loading. And then this is where we get to the meat of the implementation here. So this function run will take a TaskEither of some E and A, and it will first set the state to loading. We use TaskEither from I/O. This allows us to execute a function, a synchronous function, in the context of a TaskEither. Lots of the FPTS data structures have this ability of transforming from a more primitive type with maybe less functionality to one with more functionality. Whereas I/O can only be synchronous, task is asynchronous, TaskEither has failures, I/O doesn't necessarily have failures on its own. So you're able to lift this I/O into this TaskEither workflow. So once we've set loading to true, we go ahead and run our TaskEither that has been provided. We use chain here from TE's monad instance. Once we have that running and the values come back, first thing we're going to do here, given the parameter you cite for, you configure how long you'd like for this to load so that you can simulate the amount of time it should appear that it was loading so that the user can perceive the loading screen and feel more confident in the software that we're giving them. So this next step helps us do that. So you might have noticed right when we start, we call this function, we track the start time. Performance now gives us millisecond resolution. So the next one here says when this is done executing, go ahead and run this, but don't necessarily keep the value. So anytime you see chain first in the FPTS APIs, it's always going to mean here run this effect, after the one before it, but don't keep track of the output. Chain will always keep track of the output and pass it along, whereas chain first will disregard the output. Okay, so another interesting thing you'll find pretty often in FPTS APIs is this K function, or it ends in K. K stands for Kalisli, if I'm pronouncing that right. And pretty much, if you've ever used chain, you've already used a Kalisli function. Those functions are from some value, some resolved value, to some instance of a functor, monad, anything of that kind, that's wrapping around some other kind of value. So in this case, task K means we're performing a Kalisli arrow. In this case, we don't care about the value, but we're performing a function from, in this case, no value, to a task of some other value. So this means perform a task, but disregard it, its output. So in this case, our delay function from before returns a task, not a task either. These K or Kalisli functions allow you to compose other data types that otherwise might not necessarily compose as easily. Okay, so in this case, we've now waited for the desired amount of time, subtracting the desired amount of time from what time it is now that it starts running from the time that it started, so that we always wait, in this case 600 milliseconds, just so the user can perceive loading time. And then lastly, we chain first again, so this is also an ignored value. We run another synchronous function to set the loading back to false. So this is our whole workflow. This defines everything we want to do. And lastly, since our tasks are lazy, we called that function to run it. Since this is a TaskEither, resolves with an either. And once that either comes back, we go ahead and set our value back up here. Okay, so we could run our function, we'll keep track of the state. Lastly, we have our pattern matching function that'll help us traverse all these different states, as we kind of mentioned before. So how it works, you'll provide all four of these functions so that you're required to represent all of the various states that we care about. So the implementation here, it gets the current value from the state, and we're going to use pattern matching functions for both either and either, or option and either, since that's the type that we're working with, option of an either AE. So first here, we map over the option. If the option is a none, and we are currently have the state of loading, we'll call the onLoading function. If it is not loading and it's also a none, we'll return the onNone function here. Okay, so if the option is instead a sum, it'll be an either EA. And in this case, we'll match over each of its values from the E or an A. And if it is an E, we'll call our on error. And if it is an A, we'll call on success. And as I mentioned previously, we'll also pass in whether or not it's loading. So you can capture that you have some data still, but you are loading. So we can differentiate between all our loading states. So those are the two functions that we returned back. And now we can use these as many times as we want to represent a task either in the states that it has. Alright, so let's go back up to our example and talk a little bit more about what's going on. So the next piece of state that we have here at the top is keeping track of the currently selected person. So this is, we're using an option here to represent when we have and have not selected a person, whether or not to show their films. And then the last piece of state here at the top is another custom hook called use pagination. It gives us back the current page that we're at and the ability to go back and forward. So let's take a quick look at how this works. The Star Wars API requires that the page is 1 and can increment up from there. So the starting state for our page is 1. And then our back and forward functions are helpers for updating the page. When we go back, we ensure that we go -1 unless we're already at 1, in which case it'll stay at 1. And similarly, we can add 1, ensuring it's always at least 1. And then we return the current page and then these functions to go back and forward. Okay, so now that we can paginate back and forth, keep track of our TaskEither state, let's see what it looks like to actually make a request using our TaskEither. So, given that we're executing effects anytime we call this section function that's returned from use TaskEither, the usage of that function should almost always be in React use effect if you're using React. So let's decompose this use effect here really quick. I'm going to briefly touch on this abort controller. If you're not familiar with the fetch API and being able to abort fetch requests using a abort controller, hopefully you can pick it up here pretty quickly. You create a controller, and the controller has this ability to be aborted when you call abort, and you pass this signal along to the fetch request. I'll show it to you in just a second, and that's able to cancel the request. So anytime the page changes, so if you're paginating through the previous request, if it's still going, will always get canceled before making the new one, ensuring that we're not hogging up network resources for requests that aren't going to be used. Alright, so let's decompose this a little bit more. We have this make request function. It abstracts over fetch and lifts fetch into a type safe TaskEither using a URL, B a decoder, so that we can ensure that the values that are coming out are exactly what we expect them to be at runtime, and then the abort signal that I mentioned. So here we're using TaskEither's try-catch method. As I mentioned previously, tasks are not meant to fail. But however, a lot of times you might have some promise workflows which do fail, and try-catch is one of the ways in which you can coerce your existing functionality into a world that TaskEither works. So the first function here is a promise of some value. And here we make our fetch request. This is where you pass in the signal. And if you call abort at any point, the signal will have an event that fetch will be able to use to cancel himself. But given that it's not canceled, we'll get a response back. We try to decode the JSON. We use our decoder to check to see if this is the value that we expect. If it is not the value we expect, we draw it, which really just takes a JSON tree structure and makes it into a string that's human readable. And we'll throw that error, and I'll get to what that does in just a second. But in the success case, we have this value A that our decoder ensures us to have. So in the chance that this promise rejects, like this, on this throw here, try-catch always accepts a second parameter of unknown to some other value that you want to be your left value of your task. Either in this case we chose error. So if something is already an error, we check if it is an instance of an error, and in that case we'll return an error. If it's not an error, we stringify it and coerce it into an error. Okay, So this function allows us to create a TaskEither that makes a simple GET request to the URL that we need, decodes it, and supports cancellation. Let's get back up to our example. So here we create our TaskEither, and then we call getPeople, the run function from useTaskEither, to execute this function and keep track of the state here for us. All fairly declarative. So we're making a request. We're getting our state kept up to date through the task chain that we put together in useTaskEither. So let's talk a little bit about the markup here. We have section just to wrap our content in. We have our header. If we've selected a person, it'll say Star Wars films. If we haven't selected a person, it'll say Star Wars characters. But the cool thing we got from useTaskEither is this ability to pattern match on all of the states of our TaskEither. So if you remember, we have all of these states in which we needed to handle. So I'm going to gloss over the first three quickly, but for the first case, we render none. We use null just to say, hey, don't render anything. When it's loading, we have this little loading indicator, really basic, and we have a really simple error message in case we get any errors along the way. So all three of those get handled for us. And then in the success case, what we've been able to determine here through our people payload decoder, which I've mostly brushed over until now, it will be definitively an object with a count and of a number, and results being a non-empty read-only array of people or a person. Okay, so once we have the results here, we actually want to pattern match on yet another thing to see if we have selected a person or if we have not selected a person. So in the case that we have not selected a person, we have this people view. People view is responsible for taking these results, rendering our grid of people, showing what page we're on, giving us the pagination controls for going back and forward. We'll get into that in just a sec. In the event that we have selected a person, we instead show a person view, which takes the current person to be able to display, well, we'll get into it a little bit more, but to be able to display a person's information. So let's take a quick look at people view. People view is mostly controlled only through its props. There are some memorizations here just of the start and end values. Well, these are used to represent the current range of people that you're looking through. So as you're navigating through the pagination, we'll say 1 through 10 of 82, 11 through 20 of 82, so on. But besides these computations of where we're at, given the current page, the number of people we see on this individual response, and the number of people we currently have in our array, we're able to render some basic HTML. If it's loading, we show a loading screen. If not, we show a person list, which allows us to select a person. We show a little footer here showing the pagination. Here's our buttons for going back and forward. We disable the back button when you're on the first page. We disable the forward button when we're at the end of the pagination. Pretty standard React markup here. Let's dig into person list really quick. It's just an unordered list of people. I won't get too much into the styling. Person name is just a p tag that you can click on. When you click on one of the names, it will select the person so that you can see the films that they have. So we've seen the case where no person is selected, and but we have the list of people in which we can render. So once you have selected a person, it will come down into our person view. This one's a little bit more interesting than people view, in that it also makes additional requests. So using our use TaskEither, as we did in the first example, we give it a time to load of 600, the same. But in this case, we're going to expect a read-only array of films. So we named our match in our run function match films and get films. Very similar to our TaskEither example component at the top. We have an abort controller. We return the ability to cancel these requests. So given that we have a person, we map over this list of film URLs. And for each one of those URLs, we make a new request, in this case, TaskEither of films. We use this decoder to ensure that we're getting back the film that we expect. And every one of these requests share the same abort controller. So they will all get canceled at the same time if either the person changes or you've unselected a person and the component goes off screen. Okay, so we have now right here, let's make a little break in this. We'll be able to see that we have an array, if you can't see it quite there, an array of TaskEithers of errors to films. And we're able to use this helpful function from the TaskEither module, sequence array, which you can see here, takes in a list of TaskEithers and returns a TaskEither of an array of values. It's important to note here that this will fail fast. So if any of these requests for a film ends up failing, this whole sequence will fail as soon as a single one also fails. Very similar to promise.all, for those familiar with promise.all. And then lastly, we execute or run this TaskEither and keep track of the state. So, very similar to how we were pattern matching on people. Here we're able to reuse all of our render none, loading, and error functions as we pattern match over all the states of films. And in the case that we resolve with all the films, we go ahead and render those out in an unordered list. So that brings us to the end of our code example. I hope that you're able to pick up a little something from TaskEither. Really, TaskEither is great at composing sequences of asynchronous tasks together, whereas in TaskEither is able to help you represent those asynchronous workflows that are capable of failure. It allows you a very declarative way of working with all of the possible states of your application.
Alright everyone, that's going to be it for today's video. A special thanks to Tylor for taking the time to walk us through that. In the next video, we're going to expand upon this notion of TaskEither even further by introducing a reader monad to build out this algebraic data type known as reader TaskEither. And we're going to use that as well to build a higher level abstraction that you can use throughout your application. So look forward to seeing you then.